Hello, everyone. Thank you very much for joining this session. I'm Junghwan Kim, a PhD candidate from the Department of Geography and GIS Science at the University of Illinois at Urbana-Champaign in the United States. In this presentation, I argue that the assessment of individuals' exposure to mobility-dependent environmental factors such as air pollution, noise pollution, healthy food environments, etc., can be erroneous when people's non-residential neighborhoods are ignored because of the neighborhood effect averaging problem. Moreover, I argue that ignoring people's non-residential neighborhoods can lead to inaccurate evaluations of social and racial disparities in such exposures because of the neighborhood effect averaging problem. In recent decades, air pollution is one of the important public health challenges in big cities. For this reason, geographers and public health researchers considered air pollution exposure as a critical factor that negatively affects people's health. Moreover, studies have investigated social and racial disparities in people's exposure to air pollution, which may result in the disparities of their health status. For these studies, it is widely known that one critical task is to accurately delineate geographic context where air pollution influences people. However, I found there are serious methodological limitations of previous studies when delineating geographic context. Previous studies largely used residence-based exposure assessment based on the administrative unit. So for example, some have focused on census block groups used in the United States, while others have utilized census tracts. This may exacerbate the modifiable area unit problem. However, more importantly, when previous studies delineate the geographic context, they only focused on people's home neighborhood, assuming that people are static. This can be problematic for two reasons. First, they overlook the fact that the air pollution levels are dynamic in space and time. Second, they overlook the fact that many people travel to different places to undertake various daily activities, such as go to work, shop, and medical appointments. To sum up, previous studies largely assumed people are static and overlooked non-residential geographic context. This may exacerbate serious methodological issues in exposure assessment studies, such as the neighborhood effect averaging problem. The neighborhood effect averaging problem argues that ignoring human daily mobility may lead to erroneous assessments of individual exposure to air pollution and other mobility-dependent environmental factors because it does not fully address neighborhood effect averaging. Then, what is neighborhood effect averaging? Neighborhood effect averaging is a phenomenon that mobility-based individual exposures tend to move closer to the average exposure level of the population when compared to the residence-based individual exposures. There are two situations that neighborhood effect averaging operates. The first situation occurs when the residence-based exposure level for a person is lower than the average level. In this case, this person is more likely to visit neighborhoods where exposure levels are higher than the home neighborhood. This is because individual exposure levels tend to follow the bell-shaped curve, which was empirically observed in previous studies. As a result, mobility-based individual exposures tend to be higher than the home-based exposures. This is upward averaging. On the contrary, the second situation occurs when the home-based exposure level for a person is higher than the average level. In this case, this person is more likely to visit neighborhoods where exposure levels are lower than the home neighborhood. As a result, mobility-based exposure tend to be lower than home-based exposures. This is downward averaging. Due to these two situations, individual exposures tend to converge to the average level when daily mobility is considered. This is neighborhood effect averaging. Therefore, ignoring human daily mobility may lead to erroneous assessment of individual exposure to air pollution because it doesn't fully address neighborhood effect averaging. This important methodological problem is the neighborhood effect averaging problem, or NEAP, NEAP. Today, I especially argue that the NEAP can be a serious methodological problem, especially when researchers evaluate the social and racial disparities in people's exposure to environmental factors without considering human daily mobility. There are two important cases. Please recall that neighborhood effect averaging is a phenomenon that individual exposures tend toward the average level of the study population when people's mobility is considered. Because of the neighborhood effect averaging, the evaluation obtained from using people's home-based assessment can be underestimated. Imagine group A has a typical level of daily mobility, while group B has a limited daily mobility. Imagine also that the average residence-based exposure level of these two groups is similar to each other. Due to downward averaging, the mobility-based exposure level of group A becomes lower than the home-based exposure level. However, the mobility-based exposure level of group B remains the same because they have a limited daily mobility. Therefore, using residence-based exposure level can lead to underestimation of this parity in exposure between two groups. Furthermore, group B is important because they are doubly disadvantaged in exposures. They do not experience downward averaging even if they live in high polluted neighborhoods, unlike group A. Second, because of neighborhood effect averaging, the evaluation obtained from using people's home-based approach can be overestimated. Imagine there are groups C and D who have a typical levels of daily mobility. The average residence-based exposure level of group C is significantly lower than group D. Due to upward averaging, the mobility-based exposure level of group C becomes higher than the home-based exposure level. On the contrary, due to downward averaging, the mobility-based exposure level of group D becomes lower than the home-based than the residence-based exposure level. Therefore, using residence-based exposure level can lead to overestimation of disparity in exposure between two groups. Therefore, when assessing the socio-demographic disparities in people's exposure to air pollution, ignoring human daily mobility can overestimate or underestimate the assessment. Given the fact that current public policies largely adopt residence-based approach, their evaluations of socio-demographic disparities in exposures may be erroneous. However, only a few studies have investigated the effect of neighborhood effect averaging problem on environmental inequalities. To fill this important research gap, I asked two research questions. First, how does the NEAP affect the evaluation of social demographic disparities in people's exposures? Second, which social groups are doubly disadvantaged in exposures? The study area is Los Angeles area in California, United States. I choose Los Angeles for its severe air pollution and traffic congestion. For example, it ranks the first out of 200 cities in the United States for its severe air pollution. Also, a recent public survey reveals that about 80% of people living in LA think air pollution is an important environmental issue. Next, the main data of this research is an individual activity travel diary survey, which is part of the National Travel Survey conducted in 2017 in the United States. The survey contains detailed information about participants' one-day activity travel patterns, as well as socio-demographic attributes. I particularly select about 4,000 people living in Los Angeles. First, I use hourly ground level ozone data collected at monitoring stations on one summer day in 2018. I use co-correlating estimation to create 24 hourly ground level ozone surfaces by using data of ozone, nitrogen oxide, and temperature. After testing different variogram models and parameters, the Gaussian model was chosen because of its best model fit. Moreover, by integrating individual activity level diode data and hourly estimated ozone surfaces, I estimate individual ozone exposure in two ways. The first is residence-based exposure assessment, assuming people are static at their home location. The second is a mobility-based approach by using GIS science methods and time geography framework. Further, I use two subsamples. The first subsample consists of participants who report their weekday trips. The second subsample consists of participants who report their weekend trips. I investigate the effects of the NEAP on the evaluation of social and racial disparities in exposures by using 4 spatial regression models. Independent variables include key sociodemographic variables. For the dependent variable, model 1 is residence-based individual exposure of weekday participants, and model 2 is mobility-based individual exposure of weekday participants. By comparing the direction, magnitude, and the statistical significance of each estimate between two models, I can investigate the NEAP. Before moving on, are you ready to learn about interesting results of my research? So if so, please show the thumbs up icon through the Zoom window. But I just realized that there is no thumbs up icon today in this webinar setting. So I just assume that you are excited to learn about the results. So let me keep moving. Let's address the first research question. Here is the regression result. Yes, I understand too many numbers are presented. So let me show the summarized result. First, the results reveal that although African American and low-income people tend to have lower home-based exposures, they are not significantly associated with mobility-based exposures. Second, employment status is significantly associated with mobility-based exposures, but it is not associated with home-based exposures. Therefore, the results suggest that using residence-based assessments can overestimate the disparity in exposures between African American and white and low and middle income people. Also, the results suggest that using residence-based assessments can underestimate the disparity in exposures between workers and non-workers. I further investigate the spatial regression model results in detail by focusing on race. This blue solid line indicates home-based exposure of white people, while this blue dotted line indicates those of African American people. Now, as the regression results indicate, you can see that overall white people have a higher home-based exposure level than African American people. However, you can see that the red solid line is significantly lower than the blue solid line, indicating that white people experience downward averaging. However, the red dotted line indicates is very similar to blue dotted line, indicating that African American people do not experience neighborhood effect averaging because of their limited daily mobility. The results further illustrate that similar patterns are observed for employed status and income level, corroborating our results obtained from the spatial regression analysis. To sum up, the results indicate that the difference in residence-based exposure between two groups can be overestimated or underestimated when human daily mobility is ignored. This is because of different manifestations of neighborhood effect averaging problem of each group. Next, I focus on the second subsample of consisting of weekend participants. Here is the results of model 3 and 4. So again, I will show the summarized version. Actually, the results indicate that there was no significant association in both model 3 and 4. There can be two reasons for this. First, on the study timeline and study area of this research, this is because there is a smaller regional variation in ozone concentration level on the weekend than on the weekday. Second, the level of daily mobility is significantly lower on the weekend than on the weekday. So for example, the duration of out-of-home activities on the weekend day is smaller than that on the weekday. Let's move on to the second research question. Here I use spatial autologistic regression to see the association between individuals' characteristics and a binary variable indicating whether an individual is doubly disadvantaged or not. The doubly disadvantaged people are defined by whose residence-based exposure level is relatively high, as well as whose mobility-based exposure level is higher than the residence-based exposure level. The results indicate that for those who live in high air pollution neighborhoods, non-workers such as unemployed and homemakers and retired have significantly higher odds of being doubly disadvantaged in air pollution exposures than workers. This is because non-workers tend to spend most of their time in their residential neighborhoods, as the spatial entrainment hypothesis suggests. Moreover, comparison of the space-time path visualization of workers with non-workers corroborate these findings. The space-time paths illustrate that non-workers have a lower level of daily mobility than workers, and explain why non-workers have a higher chance of being doubly disadvantaged. The results of my study provide important implications for environmental inequality policy. Policymakers should pay more attention to human daily mobility when evaluating socio-demographic disparities in exposures, because ignoring human daily mobility can exacerbate the neighborhood effect averaging problem. Especially, policymakers should pay special attention to the doubly disadvantaged group to fully mitigate their socio-demographic disparities in people's exposures. This is because doubly disadvantaged people have limited daily mobility and do not experience downward averaging, which was experienced by most other people living in high pollution neighborhoods. In other words, human daily mobility or immobility provide another important dimension in environmental inequality. In summary, there are two important takeaway points from today's presentation. Number one, the neighborhood effect averaging problem is a serious methodological problem that leads to erroneous assessments when evaluating social demographic disparities in people's exposure to mobility-dependent environmental factors. Number two, non-workers constitute the doubly disadvantaged groups that do not experience downward averaging. In the interest of time, I was not able to deliver some details of my works. Since all of these works have been published in journals, if you want to know more about the results, please refer to these papers. Thank you very much for your attention, and I hope you stay healthy and safe during this pandemic. Thank you.
There is a couple of questions coming from SM Labib. His first two questions. Did you create a dedicated travel route and measure the exposure when people traveling, or are they estimates of different locations?
Yeah, thank you very much, your question, Labib. So regarding the first question, since let me share my screen again to provide more detailed answer. Yes, so the activity travel diary data of the 4,000 people unfortunately does not have the detailed routes that people take. It only has original location, destination location, and departure time, some detailed information of the activity, not the trip information. Because this is like a nationwide large size sample travel survey, they did not able to collect all the detailed travel routes. So what I did in this research is just use the Google Maps API, and by assuming that people follow the shortest path routes between each two locations, and to create this kind of a detailed space-time path based on this travel diary data. So that was your first question. And the second question is, let me read.
The second question is related to data. How much data do you think we are able to be able to collect on the personal level around there to measure these types of exposures?
Oh yeah, thank you very much. Also, again, your question. So let me also share my screen again. So I understand that this travel diary data is some kind of time consuming and resource consuming to collect this data. So I know that many people, researchers recently use real-time mobile sensing data, but that is also have some limitation because it has some, it is costly and it cannot be easily used for large sample surveys. So as an alternative to both of these methods, there are also many other researchers, as you already may know, that are using like mobile phone tracking data or smart car data or Google Maps location history from Android phone or geotagged social media data. But it is widely known that this kind of mobile data may involve in algorithmic uncertainty, indicating that the location may involve some uncertainty because, for example, mobile phone data is largely based on the cellular tower signal, and that may not necessarily capture the true location. And also the geotag Twitter data, it has some sampling bias or something. So I would say that all data have some disadvantage and advantages. So I believe that by widely using this kind of data in different settings would provide more meaningful knowledge about these exposure studies and environmental health studies. And regarding the second aspect that you mentioned about the privacy, yeah, that is also very important because there's recently these geoprivacy and geoethics issues have been become very important recently. So our research team at the University of Illinois at Urbana-Champaign, collaborating with University of Michigan, and Harvard University, we are also assessing and developing various geoprivacy protection tools that can be applied to this kind of location data so that we can maximize the geoprivacy protection of human subjects. Hope this answers your questions.
Thank you. I've got one quick question. Have you managed to link, or are you planning to link these different mobility profiles and neighborhood profiles to health data? And does it make a difference?
Oh, yeah. So let me also share my screen. So yeah, thank you very much for your question. So your question is about the linkage between my research with the actual health outcome, right?
Yeah.
Yeah. Thank you very much. So due to some kind of time limitations that needs to be done during my doctoral dissertation study, because this is my doctoral dissertation research, I was not able to actually link my research with the actual health outcomes because, but this shows some kind of brief illustration. So for example, this green, this is hourly ozone level, and the color indicates potential adverse health impact by ozone. So red means poor health impact, and the green means okay. So this left one shows workers, and the right one shows non-workers. And since workers in this area was able to travel different places, and as you can see during the daytime, they was able to expose lower exposure level, some kind of healthier area, because their workplaces is actually have better air quality than their home places. But however, these people are just stick to their home because of their limited daily mobility. So their health, their air pollution level keep poor. So their health impacts is keep poor during the daytime. So this is kind of some piece of evidence that my research about the NEAP can be also related to health outcomes. But I have to admit that the investigation of these exposures on the actual health outcome is somewhat very complex. We need to consider so many different other things. So for example, like for today's presentation, I just simply assume that the overall cumulative exposure level is important, but actually the previous studies argued that there can be many different temporal uncertainties, such as here, momentary responses, there would be time lag, the frequency would be important, the duration would be important, But due to my limited resources for my PhD program, I was not able to do that. But I'm graduating this May, so after my PhD, I'd like to actively collaborate with many public health researchers or epidemiologists to really delve into this actual link between neighborhood effect averaging problem and health outcomes. Yeah, I hope this answers your question.